everyone, and welcome back to Quantic Academy. So today we will be talking about Newton's three laws, okay? And these are the basic laws that govern basically the foundation of the entirety of physics. They're very useful in all of physics, and you can actually use them to explain a lot of the real world around you. Okay, so what are Newton's laws? Well, Newton's first law states that things will move in a straight line at constant speed, or it will remain at rest, which means stationary, unless acted upon by a force. Okay, let's see what that means. So, if I don't put a force on something, it will stay still. It will be stationary, right? If I don't put a force, it will just remain there. And so, that means it is at rest. That's what at rest means. But if it's moving at like 5 meters per second to the right, let's say, and I don't put a force, well, if I don't put a force, I'm not going to make it speed up. But that also means I'm not making it slow down, because I'm not putting a force to make it slow down. I'm not putting a force to make it speed up. So it will remain at the same speed. And why straight line? Because I'm not putting a force to change the direction. I'm not putting any force. And so if I don't put any force, if it's stationary, it will remain stationary. If it's moving in a straight line at constant speed, it will continue to move in a straight line at constant speed. Okay. Now, let's move on to Newton's second law. So what happens when I put the force there? Well, here we go. If I put the force there, then I will cause acceleration. Why acceleration? Well, if I have an object and it's not moving, that means it has a speed of 0 meters per second, right? And so if I make it move, if I put a force and make it move to like 5 meters per second, I've changed the velocity. And so that means there's acceleration. I put acceleration, I accelerated it. That's what acceleration means, change velocity. And so force causes acceleration. Force does not cause it to remain at the same speed, as we saw in Newton's first law. It will remain at constant speed if there's no force. So if there's a force, it must be changing the speed, thus causing acceleration. And then the reason it's F equals ma is because the force is proportional to the mass. This means proportional. And why is that? Well, because if I have a heavier object, I will need to put more force to accelerate it. If I have a lighter object, I will put less force to accelerate it, right? It's a lot easier to accelerate a piece of feather, for example, rather than an elephant. Okay? And last but not least, we move on to Newton's third law. You may have also heard this. This is quite famous as well. If an object exerts a force on another object, then that other object must exert an equal but opposite force back onto the original object. Okay, what does that mean? So basically, if I am standing here on top of the floor, right, I'm exerting a force on the floor because gravity is pushing me down. Okay, gravity is pushing me down, so I'm pushing on the floor with the force of gravity. But Newton's third law says that because I'm pushing on the floor with the force of gravity, then the floor also pushes on me. It also pushes on me with the same equal force. And this force is called the normal force, which we denote by N. Okay? So that's what that means. And you can feel this as well. If you stand on the floor, you don't just go through the floor. You feel the floor pushing back up on you. And that is the normal force. That's Newton's third law. If I punch someone in the face, yeah, I'll exert a lot of force on the body. But that body also exerts a lot of force on my hand. My hand will hurt. I will feel the punch. I will feel their face on my hand. I will feel the power on my hand. I will probably damage my hand as well. So that's Newton's third law. If you exert a force on an object, then that object will exert the same force on you. Okay, so those are Newton's three laws. They serve the foundations of physics and the main fundamentals that are used in pretty much all of physics, from electricity to particles to heat, even everywhere. They're so fundamental. And yeah, so thank you guys for watching today's rendition of Quantic Academy. If you liked it, then leave a like on the video, subscribe to our channel for more wonderful content, and see you guys next time.